What is the standard time?
The cesium-133 atomic clock is the standard for the second.
What can exert a force?
The first answer that might come to mind is that a person can exert a force. He or she can throw a ball, pull the string on a bow to shoot an arrow, push a chair across the floor, or pull a wagon up a hill. Many animals can do the same thing, so one might say that living organisms can exert forces.
What is a wavelength?
The distance from one point on the wave to the next identical point, the length of the wave.
What is the standard time?
The cesium-133 atomic clock is the standard for the second.
How were the first mirrors made?
People have seen their reflections in water for hundreds of centuries. But some of the earliest signs of human-made brass and bronze mirrors have been mentioned in the Bible and in ancient Egyptian, Greek, and Roman literature. The earliest glass mirrors, backed with shiny metal, appeared in Italy during the 14th century. The original process for creating a glass mirror was to coat one side of glass with mercury and polished tinfoil. The German chemist Justus von Liebig, 1803–1873, in 1835 developed a method for silvering a mirror. His process consisted of pouring a compound containing ammonia and silver onto the back of the glass. Formaldehyde removed the ammonia, leaving a shiny metallic silver surface that reflected the light. Today, most mirrors are made by evaporating metallic aluminium directly on the glass.
What is the principle of superposition?
When two waves overlap, they don't crash and destroy one another. Instead, they pass through each other without interaction. The graphs below show two waves approaching, overlapping, and moving away. They continue to move at the same velocity throughout. The arrows show their motions. The dotted drawings show the individual waves while the solid drawings show the resultants. The amplitudes of the two waves add together, producing either a larger wave if they are both positive or both negative. They produce a smaller wave if one is positive and the other negative. In fact, as shown, they can produce no amplitude at all. The large amplitudes are called constructive interference. The reduced amplitudes are called destructive interference.
What is angular momentum?
Equal to the product of its moment of inertia and its angular velocity.
What is three-dimensional, 3D, vision?
Seeing in 3 dimensions, which is how a person with normal eyes sees. Means that in addition to perceiving the dimensions of height and width, such as seen on a piece of paper, a poster, or a TV or movie screen, one can see the third dimension of depth. We see real objects in 3D because we have two eyes that see slightly different perspectives of the same view. The combination of these views, when interpreted by our brain, gives us the ability to perceive depth, the third dimension. If you close one eye, your ability to perceive depth is eliminated. With only one eye, the world won't look very different to you. But you'll experience difficulty in judging distances.
What is the relationship among frequency, wavelength, and velocity?
Suppose you shake a rope up and down at a constant rate. The rate or frequency is the number of times your hand is at the top of its motion per second. As the waves move along the rope, the distance between the crests of the rope, the wavelength, will remain the same. The wavelength depends both on the frequency of oscillation and on the velocity of the wave along the rope. The relationship is velocity equals frequency x wavelength, v equals x, or wavelength equals velocity slash frequency, x equals v slash f. Therefore, if the frequency of a wave increased, the wavelength decreases while the velocity, being a property of the medium, rope, doesn't change. The frequency and wavelength are inversely proportional to each other.
Why was plutonium used in bombs?
Plutonium is not found in nature, but it is produced in reactors by bombarding uranium-238 with neutrons. Plutonium-239, 239Pu, can be fissionied by slow neutrons, and so could be used in weapons. In December 1942, Hanford, Oregon, was chosen as a site for reactors that would produce plutonium. Hanford was selected because it was isolated but also on the Columbia River, which afforded a source of cooling water.
What is a voltaic pile?
Or battery in which chemical energy is converted into increased energy of electric charges.
What is Newton's first law?
If there is no net force on an object, then if it was at rest it will remain at rest. If it was moving, it will continue to move at the same speed and in the same direction.
What is aerodynamics?
An aspect of fluid dynamics dealing with the movement of air.
What is an umbra?
Area of the shadow where all the light from the source has been blocked.
What is biophysics?
Study of the physical interactions of biological molecules.
What is a horsepower, HP?
Unit of power. 1 HP equals 746 W equals 0.746 kilowatts.
What is a synthesizer?
Electronic device that generates, alters, and combines a variety of waveforms to produce complex sounds.
What is a secondary rainbow?
Reversed color spectrum caused by an additional reflection of the light inside water droplet.
What is absolute zero?
Temperature at which molecular motion is at a minimum.
How fast does sound travel?
Light travels almost 1 million times faster than sound, specifically, 880,000 times the speed of sound. Light and all electromagnetic waves travel at a speed of 3x 10 meters per second. While the speed of sound is only about 340 meters per second or 760 miles per hour on a typical spring day.
On what does the gravitational field, like that of Earth, depend?
Newton demonstrated that the gravitational force on one object caused by another is proportional to the product of the masses of the two objects divided by the square of the distance between them. The gravitational field of an object would then be the force divided by the mass of the object on which the force is exerted. The symbol used for the gravitational field is g, and g is the so-called universal gravitational constant. It is called universal because it is the same for objects made of any material and of any mass, from a 1 kilogram apple to a galaxy. The equation that describes the gravitational field at a specific location is G equals gm/r2, where m is the mass of the attracting object and r is the distance from the center of this mass to the location in space. The gravitational field is a vector quantity. Its direction is toward the center of the attracting object. Well, consider its magnitude shortly.
Are protons and neutrons the only particles containing up and down quarks?
In the 1950s, new particles with masses in between those of the electron and the proton were found. They were given the name mesotrons, where meso meant intermediate. This was soon shortened to meson. The most commonly produced meson in particle accelerators is the pi meson or pion. Pions can be positively or negatively charged or unchanged arged. In the quark model, mesons are composed of a quark and an antiquark. It is also possible to create particles with different combinations of 3 up and down quarks. These particles have higher masses than protons and neutrons and can only be created by colliding protons and neutrons together with very high energies. Examples are the combinations UUU with charge +2 and the DDD with charge -1. These particles decay via the strong interaction. The UUU decays when its extra energy creates a pair. The D quark replaces one U quark in the UUU particle, resulting in a proton, and the 5 combines with the extra U quark to form At+.
What is a pewter?
An alloy of tin with copper, bismuth, and antimony.
What is the Schrödinger's equation?
Equation of the wave function of a particle. Wave function is related to probability of finding particle at a specific location.
What is pressure of air?
At sea level about 101 kPa.
What is the zeroth law of thermodynamics?
If objects A and B are in equilibrium and B and C are in equilibrium, then A and C are also in equilibrium.
How efficient are levers?
The only place where friction can occur with a lever is at the pivot point. So, as long as friction is minimal there, the lever can approach 100% efficiency.
What is the rolling friction?
The result of deformation of either the rolling object or the surface.
What is a Large Hadron Collider, LHC?
Very high synchrotron at CERN near Geneva, Switzerland.
What is the Leyden jar?
Water can be stored in a jar.
What is an electromagnetic wave, M?
Two coupled transverse waves, one an oscillating electric field, the other a corresponding magnetic field perpendicular to it and perpendicular to motion of wave.
What is a liquid?
State of matter in which the forces keep the atoms close together, but they're free to move. A liquid is a fluid that flows freely and assumes shape of its container.
On humid summer days, why does the sky take on a white or grayish appearance?
When high amounts of humidity are in the air, water molecules are more prevalent than on a cool, dry day. Water molecules, which have 2 hydrogen and 1 oxygen atom, are larger than oxygen and nitrogen found in the air. And the size of a molecule plays a significant role in what frequencies of light are scattered. When white light encounters a larger molecule or dust particle, larger wavelength light will be scattered. Whereas if a smaller molecule is struck by white light, smaller wavelength light will be scattered. Snow, beaten egg whites, and beer foam look white for the same reason. If the water or smoke is dense enough, then all light waves are scattered many times, and the cloud looks gray.
Is Earth's atmosphere transparent to infrared and ultraviolet radiation as well as to light?
Oxygen and nitrogen, the two principal components of our atmosphere, are transparent to light and to most infrared, IR, and ultraviolet, UV, wavelengths. Infrared from the sun helps warm Earth and long wavelength. Ultraviolet is necessary for our bodies to produce vitamin D. Too much UV, however, harms the skin, and may damage our DNA. A high-altitude layer of ozone in our atmosphere protects Earth from all but a small fraction of the UV radiated by the sun. Ozone molecules have 3 oxygen atoms as opposed to the 2 in oxygen gas. In recent years, large and growing holes in this protective layer have developed due to the emission of chlorofluorocarbon (CFC) molecules from things such as escaped gases from refrigerants and aerosol propellants. Because these gases are no longer being manufactured and existing stocks are gradually being replaced, the growth of the holes should eventually stop. Carbon dioxide, methane, and water vapor are transparent to light and short-wavelength infrared radiation, but are opaque to the long-wavelength infrared emitted by warm objects. They are called greenhouse gases. These gases pass the IR rays that warm Earth but reflect the IR rays emitted by the warm Earth back to the ground. Thus they act as an insulating blanket for Earth. Over the past decades, the amount of carbon dioxide in the atmosphere has increased dramatically. Much of the increase is due to human activity. This increase is likely to lead to a warmer Earth that could shift weather patterns, disrupting food production, causing shifts in locations of forests and animals, and, by melting polar ice, increasing sea levels. The degree of warming and its impact on Earth and humans is under intensive investigation.
What is frequency modulation, FM?
M-wave frequency changes to represent transmitted information.
What is pneumatics?
Whereas hydraulics uses liquids to achieve mechanical advantage, pneumatics uses compressed gas. Since gases can be compressed and stored under pressure, releasing compressed air can provide large forces and torque for machines such as pneumatic drills, hammers, wrenches, and jackhammers.
Who was the Doppler effect named after?
Johann Christian Doppler, 1803 to 1853, the Austrian mathematician for whom the Doppler effect is named, proposed in 1842 that the color of double stars rotating about each other would depend on whether the star was approaching or receding from Earth. The effect was too small to be measured. But in 1845 Christophorus Henricus Didericus Buys Bal Lot 1817 to 1890, set up an experiment using had 2 sets of trumpeters. One set remained at rest while the other was on an open railway car traveling at the then fantastic speed of 40 miles per hour. Although both sets of trumpeters played the same note, the change in tone was clearly heard. Doppler later extended his theory to the case when both sound source and observer were moving. French physicist Hippolyte Fizeau, 1819 to 1896, later extended Doppler's theory to light.
What would happen if the same ball rolled off a table?
To answer this question, you should define a coordinate system. One axis points down, the other, perpendicular to the first. Points in the horizontal direction of the rolling ball. The force of gravity acts in the downward direction, causing the ball to accelerate downward. But there is no force in the horizontal direction, so the ball's horizontal speed would not change. Because only the downward acceleration affects its fall. It would hit the ground at the same time that a dropped ball would. The path the ball takes is a parabola. Galileo's principle of relativity, not Einstein's, can help you understand this result. Galileo imagined a sailor dropping a ball from a high mast on a moving sailboat. The sailor would see the ball drop straight down. But an observer on the shore would see the ball having a horizontal velocity equal to the velocity of the boat. Therefore, this observer would see the ball's parabolic path. But both would agree when the ball hit the deck of the boat at the same time. Galileo said that the laws of physics are independent of relative motion. This statement is called the principle of relativity.
How much energy is needed to change the state of water from ice to water to steam?
The amount of energy needed to change phase is called latent heat. The latent heat involved in the transition from solid to liquid is called the latent heat of fusion, while the energy involved in the transition from liquid to gas is called the latent heat of vaporization. For water, the latent heat of fusion is 334 kJ/kg. The latent heat of vaporization is 2265 kJ/kg. Energy must be added to go from ice to water and water to steam. But if steam condenses to water, it produces 2265 kJ for each kilogram of steam condensed. That's the reason that steam burns are so dangerous. Almost all of that energy is transferred to your skin. If water freezes, it releases 334 kJ for each kilogram of water frozen. In a freezer, that amount of energy must be removed by the freezing mechanism.
What is a secondary rainbow?
The secondary rainbow has its color spectrum reversed, is outside of the original rainbow, and is significantly dimmer than the primary rainbow. A secondary rainbow occurs because an additional reflection of the light takes place inside the water droplets. Instead of reflecting once in the water droplet, the light reflects twice inside the water, reversing the order of the colors. The secondary rainbow appears between the angles 50 degrees and 54 degrees.
How do day/night rear-view mirrors function in vehicles?
When drivers traveling at night encounter a bright light from the vehicle behind them shining in their eyes, many will flip a tab on the underside of the rear view mirror to deflect the light up toward the ceiling of the car. The silvered surface of the mirror reflects approximately 85 to 90% of the incident light on the mirror, which is now directed toward the ceiling. The remaining 10 to 15% of the light is reflected by the front of the glass on the mirror. The mirror is wedge-shaped, thicker at the top than at the bottom. Thus the front surface is angled downward to allow the much smaller amount of light to be reflected into the driver's eyes.
Why is it often cooler to wear white clothes, rather than black clothes?
White surfaces reflect all the colors of the rainbow, whereas black absorbs all the colors in the light spectrum. The absorption of this energy heats the black material, increasing its temperature. This, in turn, increases the temperature of the air between the clothing and the person. So white, which absorbs much less radiative energy from the sun, is cooler in hot climates.
What is a Doppler effect?
Change in frequency of a wave that results from an object's changing position relative to an observer.
How is Earth's magnetic field oriented?
Because opposite poles attract. The north pole of a hanging magnet or compass must point toward a south pole. So, the south pole of Earth's magnet must be near the north geographic pole. The poles are actually far below Earth's surface, so Earth's field is not parallel to its surface.
What is a light year?
Distance that light travels in 1 year. 9.4605 x 1012 kilometers or about 6 trillion miles.
What is weightlessness?
Weight is defined as the force of gravity. Strictly, then the only way one can be weightless is to be so far from any massive object, like a planet or star, that the gravitational field is zero. No human has achieved this state. In a satellite, the gravitational field is about 80% as large as it is on Earth's surface. So the force of gravity on an astronaut in the satellite is not much smaller than it is on the astronaut on Earth.
What is a torsional wave?
Material is not only displaced vertically, but also twists in a wave-like fashion.
Does the dimension of an antenna play a significant role in the reception of an electromagnetic wave?
The length of an antenna determines the frequency that it best receives. The most efficient antennas have a length equal to half the wavelength of the wave it is receiving. This allows the induced electrical current in the receiving antenna to resonate at that particular frequency. If the antenna is a simple rod, it is most sensitive when its length is 1/4 the wavelength. A loop or coil antenna are used for the low frequency, long wavelength signals in the AM band. A half wavelength straight wire antenna would be over 100 meters long. Shorter wires or rods can be used and are more efficient if coils of wire are used to load the antenna. Home FM radio and television antennas are designed to receive a broad range of frequencies, but with less sensitivity. Antennas for the ultra-high frequencies used in digital high-definition televisions are very short and can be easily mounted outside on rooftops or on top of television sets.
What are the types of waves?
Transverse and longitudinal waves are two major forms of waves. A transverse wave can be created by shaking a string or rope up and down. Although the string moves up and down, the wave itself and its energy moves away from the source, perpendicular to the direction of the oscillations. The oscillations in longitudinal waves move in the same direction that the wave is moving. The medium in longitudinal waves alternately pushes close together, compression, and separates from each other, rarefaction. The best example of longitudinal waves are sound waves, which are a series of back and forth longitudinal oscillations of atoms or molecules that form alternate regions of high and low pressure in a medium such as air. Water waves are a combination of transverse and longitudinal waves that move in circles. Just as in the case of transverse and longitudinal waves, energy is transferred but matter is not moved.
Why are the angles of wings important for supersonic flight?
When a plane breaks the sound barrier, the shock wave in front of the plane has a difficult time moving out of the plane's way. In order to break the sound barrier with less difficulty, aeronautical engineers have designed more aerodynamic fuselages and efficient wing designs. As mentioned above, wings on supersonic planes must remain behind the shock front to prevent structural failure and allow the plane to maneuver safely. The swept-back wing design, as found on both military and commercial airplanes, allows the airplane to accelerate easily and faster before major pressure builds up around the wings. The delta wings, as found on many jet fighters, are large and extremely thin. To keep the wings behind the shock front while increasing lift and reducing drag. Problems can also occur when using swept back wings. As a plane moves faster, the center of lift on the wings can move too far backward, causing unbalanced forces on the plane, which can affect the maneuverability and safety of the plane.
What plays the role of mass in rotation?
Mass is defined as the net force on an object divided by its acceleration. By analogy, then, the property that takes the place of mass should be the torque divided by angular acceleration. The property is called rotational inertia or the moment of inertia. It depends not only on mass, but on how far the mass is from the axis of rotation. The further the mass is from the axis, the larger the moment of inertia. If you sit on a swiveling stool or chair while holding heavy weights, the further you extend your arms, the more difficult it is for someone to start you rotating. That is, it will require more torque to achieve the same angular acceleration.
What wavelengths of light are our eyes most sensitive to?
Our eyes are most sensitive to the wavelengths corresponding to the yellow and green colors of the spectrum. Flashy signs and some fire engines are painted in a yellowish-green color to attract our attention. Even simple objects such as highlighters, used to emphasize words or phrases while taking notes, are typically bright yellow and green. When we glance over something or see an object out of the corner of our eyes, we are more likely to notice bright yellowish-green objects than red or blue objects. Because the eye is less sensitive to these wavelengths.
What is a dip needle?
Like a conventional compass, but the needle rotates in vertical plane.
How do convection currents create sea breezes?
During a day at the shore, the sun warms the ground and the water. The ground has a lower specific heat and so its temperature increases more than the temperature of the water. The ground heats the air above it, which rises in convection currents, and cooler air from over the ocean flows toward the shore to fill in the gap left by the rising warm air. This flow of cooler air from the ocean toward the shore creates what is known as a sea breeze. In the evening, when the sun dips below the horizon, the ground cools faster than the water. Therefore, the air over the ocean is warmer than the air over the shore, and the reverse takes place. The warmer ocean air rises while a breeze flows from the shore to the water.
How long does it take light to travel certain distances?
The table below lists some travel times for light. Some of the destinations above would require light to travel in a circular or curved path, which it does not do.
Is there a difference between work and energy? Between heat and thermal energy?
Energy, whether kinetic, stored, or thermal, is a property of an object. Gravitational field energy is a property of the gravitational field. Work and heat are means of energy transfer. Work is transfer by mechanical means. Heat is transfer between two objects with different temperatures. Examples of work are you throwing a ball, a slingshot launching a stone, a ball being caught in a mitt. Examples of heat are your hand being warmed by putting it in hot water. A bottle of soda being cooled in a refrigerator, and Earth's surface being warmed by sunlight.
What is architectural acoustics?
Theaters, concert halls, churches, classrooms, and soundproof rooms have to be designed and constructed so that their acoustic properties match their uses. In some spaces it is important that the speaker, singer, or musician or group be heard clearly in all parts of the room. A good concert hall has intimacy. Music should sound as if it were being played in a small hall. It should have liveness and warmth, fullness of bass tones. The sound should be clear, and the audience should be able to locate the source of the sound. The sound should be uniform over the entire hall. And sounds from the stage should be blended by the time they are heard by the audience. Finally, the hall should be free of noise, from air handling systems as well as outside sounds. In order to achieve these goals, an acoustical engineer must consider not only the size and shape of the hall, but also the acoustic properties of materials used on the floors, ceilings, and walls of the room, as well as chairs and other objects in the room. Even the audience and air humidity affect the acoustic properties of the room. In general, hard surfaces such as concrete, plaster, wood, and tile reflect sound, while soft materials like carpet, heavy drapes, and plush upholstered chairs absorb sound. Room shapes and sizes that create standing waves should be avoided because sound at frequencies at which the standing waves occur will not be uniform. They will be loud in some places, soft in others.
What is the structure of the atom?
Thomson pictured the atom as a swarm of electrons in a positively charged sphere. This model is called the plum pudding model, after a then favorite English Christmas treat. Americans might picture a ball of pudding filled with raisins. The New Zealand-born physicist Ernest Rutherford, 1871 to 1937, developed a method of testing Thomson's model. Rutherford's first scientific work was done in Montreal, Canada, beginning in 1898. He and Frederick Soddy conducted a study of radioactivity and radioactive materials that won Rutherford the 1908 Nobel Prize in Chemistry. Those experiments will be described in the chapter on nuclear physics, at the heart of the atom. He studied the radiation emitted by thorium and uranium, which he named alpha and beta rays. He recognized that alpha rays would be ideal probes for studying materials. Rutherford moved to the University of Manchester in Britain in 1907, where he worked with Hans Geiger. 1882 to 1945, later to invent the Geiger counter, on ways of detecting individual alphas. They determined that the alpha particles were doubly charged. They allowed the alphas to go through a window made of very thin mica, a mineral that could be cut into very thin slices. He noticed that the rays that penetrated the mica were deflected slightly more than they should have been by a plum pudding atom. With Geiger and Ernest Marsden, he directed a beam of alphas on extremely thin foils of gold. To their great surprise, they found a significant number of alphas were deflected into very wide angles, some greater than 90 degrees. Rutherford commented that it was as if a 15 shell from a naval cannon bounced off a sheet of tissue paper. The Rutherford model, as pictured above, is used in many common symbols, like that of a nuclear power plant or the flag of the International Atomic Energy Agency. By 1911, Rutherford had developed his own model of an atom. It consisted of an extremely small positively charged particle, later called the nucleus, surrounded by electrons. Although the paths of the electrons were not mentioned in the 1911 paper, it was later assumed that they orbited the nucleus as planets orbit the Sun. The nucleus was 1/10,000 as large as the atom, but had all the positive charge and essentially all of its mass. If the atom's mass was equal to n hydrogen masses, then the nuclear charge was about n/2. The electrons carry a total charge equal and opposite that of the nucleus, so that the atom would be electrically neutral. Rutherford's atom is mostly empty space.
What is the Van de Graaff generator?
Named after its American creator, Robert Jemison Van de Graaff, 1901 to 1967. The Van de Graaff generator has been the highlight of many electric demonstrations in both physics classrooms and museums around the world. The device, created in 1931, consists of a hollow metal sphere that stands on an insulated plastic tube. Inside the tube is a rubber belt that moves vertically from the base of the generator to the metal sphere. A metal comb attached to the base almost touches the belt. The rubber belt carries negative charges from the comb up the tube and into the metal sphere. There, a second metal comb captures the charges. They repel each other and spread over the exterior surface of the metal sphere. As more and more charge is carried upward, it takes more and more energy from the motor to move them up because of the repulsive force of the charges already there. The energy of the charges can reach up to 1,000,000 joules per coulomb of charge. That is, up to 1,000,000 volts.
What is bronze?
An alloy of copper and tin.
What are the limitations on simple machines?
Simple machines must, like everything else, obey the law of conservation of energy. That means that the work done on the machine equals the work the machine does plus the heat the machine puts out because friction has increased its thermal energy. Some machines are highly efficient, meaning input and output work are almost the same, while others put out only a fraction of the work put in. The drawing on page 74 shows a simple machine where the machine has warmed up. That means its thermal energy has increased. It is now hotter than its surroundings, so it transmits heat to its surroundings, which are not shown on this diagram. The output work of the machine is smaller than the work put into it. That means that for the same input force, the output force is reduced by an inefficient machine.
How does this happen?
The rod attracts positive charges and repels negative charges. Neutral objects contain equal numbers of positive and negative charges. In a conductor, the charges are free to move and so the electrons can be pushed to the far end of the object, making it negatively charged and leaving the close end positively charged. An object that is neutral but has separated charges is polarized.
What is resistance to current flow?
All objects encounter friction when moving. Electrons are no different, but we refer to the friction that electrons encounter as resistance. The electrons collide with the atoms in a wire and are deflected from their paths. For the same voltage difference, the greater the resistance, the smaller the current. Resistance causes the electric charges to lose energy. The energy goes into the thermal energy of the wire or other conductor. That is, they get hot. The thermal energy can produce heat in a toaster and heat and light in an incandescent lamp.
Where did the term horsepower originate?
The term horsepower came from Scottish inventor James Watt. The value for a unit of horsepower was determined after Watt made an extensive study of horses pulling coal. He originally determined that the average horse was able to lift 33,000 pounds of coal 1 foot in 1 minute. The conversion between watts and horsepower, HP, is that 1 HP equals 746 W equals 0.746 kilowatts. In the United States, automobile engines are rated in horsepower, while in the rest of the world kilowatts are used. In a hybrid car, the power of the gasoline engine is usually measured in HP, while the electric motor is measured in kW.
What is a specular reflection?
Light rays reflect into a single direction, as from a mirror.
What is acceleration, A?
Change in velocity divided by the time over which the change occurs, vector.
What is electricity, vitreous?
Produced when glass or precious stones are rubbed.
What materials are effective absorbers of sound?
Different materials will absorb certain frequencies of sound better than other frequencies. But some of the best absorbers of sound are soft objects. Materials such as felt, carpeting, drapes, foam, and cork are good at matching the impedance of a sound wave and reflecting back very little sound. Materials such as concrete, brick, ceramic tile, and metals, on the other hand, are effective reflecting materials of sound. That is why gymnasiums, with hardwood floors, concrete walls, and metal ceilings, have relatively long reverberation times, while concert halls furnished with upholstered seats, carpeted floors, and long drapes have relatively short reverberation times. People are also effective sound absorbers. So a full concert hall has different acoustic properties than an empty one.
How does the air become a conductor?
When the charges have enough energy to begin to ionize the air of the free electrons will form a negatively charged stepped leader that will go from the cloud and make its zigzagged and often branched trip toward the ground. This process is slow, taking a few tenths of a second. The leaders are also weak and usually invisible. The atoms in the air near the ground Feeling the attractive force from the electrons in the stepped leader, separate into ions and free electrons. The positively charged air ions from tall objects, such as trees, buildings, and towers, leave in streamers. When a stepped leader and streamer meet, a channel of ionized air is created, allowing large amounts of charge to move between the cloud and the ground. The return stroke of charge back to the cloud is the brightest part of the process.
What factors determine the amount of resistance of a conductor?
The resistance of a wire or other conductor depends upon the following. The length of the conductor: the longer the wire, the more resistance. The cross-sectional area of the conductor: the thinner, the more resistance. The properties of the material: for metals, the fewer the number of free electrons, the more resistance. The temperature of the conductor: for metals, the warmer. The more resistance: for carbon, the cooler, the more resistance.
What is a sound wave?
Created by some type of mechanical vibration or oscillation that forces the surrounding medium to vibrate.
How do liquids evaporate?
A substance does not have to boil to change from liquid to gas state. The boiling point is where the pressure of the water vapor equals the atmospheric pressure. At all temperatures there is a great variation in the kinetic energy of the molecules that make up the substance. When the molecules with high energy reach the surface, they have the possibility of escaping into the air. The process of changing from liquid to gas at a temperature below the boiling point is called evaporation. When the molecules with higher energy leave the liquid, the remaining molecules have a lower average energy, and thus a lower temperature. It is cooled by evaporation.
Why are those times chosen to calculate velocity and distance fallen?
The first 3 times are chosen so that you can explore your reaction time. Have another person hold a ruler vertically by one end. Place your finger and thumb at the lower end of the ruler, but don't let them touch the ruler. Have the other person drop the ruler and you use your finger and thumb to grab it. Note the distance the ruler has dropped in the time it takes you to react to it being dropped. Compare the distance with the first 3 distances to see if your reaction time is between 0.1 and 0.2 seconds.
How are radio telescope arrays used?
A group of 27 radio telescopes, each 25 meters, 82 feet, in diameter. spaced as much as 13 miles apart from each other in Socorro, New Mexico, is known as the Very Large Array, VLA. The signals from this group of radio telescopes are combined by a computer. Constructive and destructive interference between the signals allows the array to make very accurate measurements of the location and size of objects. Larger still are very long baseline interferometry radio telescopes. These radio telescopes are located around the world. Cables can't be used to combine the signals. So each telescope needs a very precise clock to determine the arrival time of the signals. Hydrogen masers, whose frequency is stable 1 part in a million billion, are used. Again, although the signal strength is small, the wide spacing increases the effectiveness of using interference to measure very fine details of the shape, size, and location of stars and galaxies.
How can you use GPS to find your location?
GPS, or the Global Positioning System, was developed by the Department of Defense and was made operational in 1993. It consists of 3 parts. The first part is 24 satellites in 12-hour orbits that broadcast their location and the time the signal was sent. The second part is the control system that keeps the satellites in their correct orbits, sends correction signals for their clocks as well as updates to their navigation systems. The third component is the receiver.
What is an ultrasound?
A method of looking inside a person's body to examine tissue and liquid-based organs and systems without physically entering the body.
What is the coefficient of kinetic friction mk?
Coefficient when there is relative motion between the two surfaces. Smaller than static friction.
What happens if you get close to a charged Van de Graaff?
The sphere on the Van de Graaff is a conductor surrounded by an insulator, the air. While there are strong forces on the negative charges on the sphere, they're not strong enough to break down the insulating properties of the air. If, however, you bring another object with less negative charge close to the generator, the forces on the air molecules can become strong enough to rip them apart, separating their negative electrons from the positive nuclei. A spark will jump. If that object is your finger, you'll feel a shock when the charges carried through the spark move through your body. While the shock can be painful, one produced by the kind of Van de Graaff in physics classrooms is not harmful.
Does the speed of light depend on the medium?
Waves travel at different speeds when traveling in different materials. In the vacuum of space, light travels at 299,792 kilometers per second. When light encounters a denser medium, however, like Earth's atmosphere, it slows down ever so slightly to 298,895 kilometers per second. Upon striking water, it slows down rather dramatically to 225,408 kilometers per second, 3/4 of its original speed. Finally, when light passes through the dense medium of glass, it slows to only 194,670 kilometers per second. The ratio of the speed of light in a vacuum to that in a medium is called the refractive index, represented by the symbol n. The refractive index will be discussed in further detail in the section on lenses.
How does a person hear sound?
The ear is the organ used to detect sound in humans and some animals. The ear consists of three major sections: the outer ear, middle ear, and inner ear. The outer ear, the external section of the ear, consists of a cartilage flap called the pinna. The pinna size and shape forms a transformer to match the impedance of the sound wave in air to that at the end of the ear canal by gradually funneling the wave's sound energy into the ear. To hear more sound, people can increase the size of the pinna by cupping their hand around the back of the pinna, in effect, increasing its size and funneling capabilities. Once the sound has entered the ear canal, it moves toward the eardrum, where the longitudinal waves cause the eardrum to move in and out depending upon the frequency and amplitude of the wave. The middle ear includes the eardrum, the hammer, anvil, and stirrup, the three smallest bones in the human body, and the oval window on the inner ear. The eardrum is 17 times larger than the oval window, and this difference in area makes the inner ear act like a hydraulic machine, increasing the changes in pressure on the eardrum to that on the oval window at least 17-fold. The three bones link the eardrum to the oval window. They act like a lever system to further increase pressure on the oval window. The mechanical advantage of the lever system varies with frequency, peaking at about 5 in the 1 to 2 kHz frequency range. Thus the middle ear is like a complex machine that can amplify the pressure on the eardrum by a factor approaching 100 as it transfers the energy of the sound wave to the inner ear. Muscles connected to the eardrum and the three bones can react to very loud sounds and reduce the sensitivity of the ear, thus protecting it from damage. The inner ear is a series of tubes and passageways in the bony skull. It consists of the cochlea, a spiral-shaped tube that changes the longitudinal sound wave into an electrical signal on the nerves connecting the ear to the brain. The inner ear also has three semicircular canals that sense the body's motions and give rise to a sense of balance. The oval window is at one end of the cochlea. Sound waves transmitted through the middle ear to the oval window cause a traveling wave in the fluid of the cochlea. This wave in one of the three tubes within the cochlea, the organ of Corti, causes hair cells, called cilia, to tilt back and forth. The tilting causes chemicals to pass through channels in the nerve, creating electrical impulses that travel along the auditory nerve to the brain for analysis. The further the hair cells are from the oval window, the lower the sound frequency to which they are sensitive. Thus different nerves are excited by different frequencies, allowing the ear to distinguish the sound's frequencies.
What is a microwave oven?
Uses 2.4 GHz M waves to cook food.
How is temperature measured?
Temperature is measured by a device called a thermometer. There are many different kinds of thermometers, but they all have a property that depends on temperature. The most common type of thermometer contains a thin column of liquid in a glass tube. When the temperature goes up, the liquid expands, and the height of the column increases. Earlier thermometers used mercury, a metal that is a liquid at room temperature. Because mercury is poisonous, all thermometers sold today contain red-colored alcohol. The glass tube has markings on it from which the temperature can be read. Many thermometers today are electronic. Most contain a tiny bead of a semiconducting material whose resistance varies with temperature. The bead is called a thermistor, or thermal resistor. Others contain a tiny semiconducting diode. The voltage across this diode varies with temperature. To measure very high temperatures, a wire made of the metal platinum is used because its resistance also varies with temperature, and platinum is not affected by high temperatures. Another electronic thermometer uses two wires made of different materials that are welded together. Typically the wires are made of copper and a nickel-containing alloy. This kind of thermometer is called a thermocouple and is often used in gas furnaces or water heaters to make sure that the pilot flame is burning when the gas to the main burners is turned on. Voltage and resistance will be discussed later in this book. A less accurate, but convenient thermometer is a strip of plastic whose color changes with temperature. The plastic contains liquid crystals. The geometric arrangement of molecules in the crystals depends on temperature, and so does their color. If two different metals are bonded together in a strip, when the temperature changes, the strip will bend. Because there are two metals, often brass and steel, the device is called a bimetallic strip. This kind of thermometer is often used in household thermostats. This thermometer is similar to one developed by Galileo. The objects inside the tube have varying densities that rise or fall, depending on the temperature.